Inverse variation. Oh my goodness. Okay, so let's read this guy. This says a gas law states that the volume of an enclosed gas varies directly. Hey, that's not different. That's not inverse variation. It says inverse varies directly as temperature and inversely as pressure. Ooh, there's that new word, inversely. So inverse variation is our new concept here. We got varies directly, which is what we already know, and then varies inversely. So how are we going to use this information? What does inversely mean? So that we can set up an equation. Okay, we got more information. Let's go ahead and identify this information really fast before I talk about what inversely means. And then it says the pressure of gas is 0.75 kilograms per square centimeter. So let's write that out. The pressure is 0.75. I don't know if I should use P as the variable, but I'm going to use it anyways. Kilograms per centimeter squared. And we have this other one. It says per centimeter squared when the temperature is 294 K. Okay, so we got temperature 294 K and the volume is 8,000. Guys, I don't know if you know what I'm trying to do here. I'm trying to identify all my numbers and write them down so I can have all this information written down, because trying to hold it all in my head does not make it easy for me to figure out what I'm supposed to do next. And so I have 8,000 cubic centimeters cubed. So guys, here's the textbook language. Just kind of sums it up for you. When you start seeing words like this, that's when you're dividing the variable, dividing K by that variable instead of multiplying. So y varies inversely as x, so this would be y varies inversely as x, and so the K goes on top, the constant of proportionality, and then, or you can see it like y is inversely proportional to x. So in our problem, it says the volume varies inversely as pressure. So which one gets divided right here? Y varies inversely as x. So you see how x is dividing the constant of proportionality. Volume varies inversely as pressure. So we have, let's identify some of these variables. We got a V right here, that's your volume. We got pressure right here. As soon as I see varies directly, I'm thinking of K. So this would be volume, the K, and varies inversely as pressure. So I'm gonna put P right there. So the P would be on the bottom. But now because this problem is mean, actually I think of K when I see varies. It also throws in directly as temperature. There's another variable right there. That means you're multiplying K by T. So see, it varies directly as to temperature and inversely as to pressure. So now our job is to write an equation. Now I identified a P, V, and a T already, which is helpful because if I had a V, a T, and a P, I can find the K, and that's what I need right here to make this problem, this equation, complete. And so let's plug in all our stuff. We have, I'm going to do 3/4 because I don't like decimals. We have K, or T right here is 294 being divided by the pressure, which is 8,000. And now let's simplify. I multiply both sides by 4. Those 4's cancel out. Multiply this side by 4. This 8 would become a 2, and that 4 would be gone. So you have 2,000 on the denominator. And then to get the K alone, let's go ahead, let's multiply the reciprocal of the 294 over 2,000 to both sides. And so we have 3 equals, let's say, I'll just simplify it really quick here. We have 294 times K over 2,000. Multiplying this by 2,000 over 294. What do we do? One side, you got to do the other side. So we got 2,000 over 294 here. And I'm just going to multiply the 3 to the 2,000. 6,000 over 294. And it looks like since they're both even, I can go ahead and try to simplify that. If you could think of a bigger number that divides both of them, you're amazingly awesome. You should do it. I'm just going to divide by 2. So this is going to be 3,000. And this is going to be 147. And actually, I can't think of something that divides 3,000 over 147 off the top of my head. I would definitely use a calculator for that. So if you got this, you're good. I don't allow calculators on a test, but I wouldn't put these big numbers on a test. All right, so we would have our equation. Our equation would be the volume is, we have 3,000 over 147 is our K, and that's multiplying to T. That's being divided by P. And we could rewrite this. We can multiply the top and the bottom by 147, and so it would be 3,000 T over 147 P. That's a T right there. So any of these work. This one's better because it doesn't have a fraction inside of a fraction. The next question says, find the pressure when the temperature is 3,000, so we got a P, that's 3,000, and the volume is 7,000. So now we got to find a T. So we just got to plug in our stuff and then chug away. So the volume is 7,000, and we have our temperature, so it's 3,000 times the temperature, which is 300, divided by 147p. Okay, so 3,000 times 300, that'll be 9. Let's see, 1, 2, 3, 4, 5, 900,000. And then what we would do is kind of the same thing that we did before. We're going to multiply both sides by the reciprocal. So we're going to go 147 over 900,000. And multiply it to the other side also. This would become a 1 right here. And then we would have 1 over P. And then this side, I'm going to divide this by 1,000 because I can take 1,000 out of that 900,000. So I just have 7 times 147 over 900. And then we got to get that P flipped. So first let me multiply 147 times 7. Alright, so we got 1,029. And then if I multiply this side by P and multiply this side by P, that would be it. And then we would have to do the reciprocal thing again. It looks like I made an extra step for myself. So if you guys see another way you could have done it, then you guys should do it that way. Multiply both sides by the reciprocal again, and there you have it. That's your pressure. What's my label for my pressure? It is, no, is that my pressure? It's kilograms per centimeter squared. I know that because right here, 0.75 is kilograms per centimeter squared.